seems... Are we actually live right now? Yeah, we are. Nice. That's really cool. Yeah. I'm just gonna pause the music here to just listen to myself. Yeah, we are. Nice. That's really cool. Yeah, that seems to work actually. Very nice. Alright, so I have the chat here as well. Yeah, that's really good. Okay, so today we're gonna try to learn the library Pytorch. And I'm probably just gonna stream like a Pytorch tutorial until I've learned the whole library, basically. And it's gonna take a long time. Real long time, dude. But let's try this out. So we're first of all gonna try to make a GitHub repository to save all our data and also create a directory on my local computer here. And I'm obviously using Linux here and having some low chill music in the background. But, and I have also customized, I can actually close, you know what, just close all, I can show you guys around. So this is basically my desktop setup right now. And everything here is essentially a window manager, which is Qtile. It's written in Python. And I'm using the Linux distribution Ubuntu right now. So I've combined like Qtile and Ubuntu and some themes and so on. So it's really cool. It's really easy to execute programs and start programs and so on, and also to type in the terminal. So it's really nice actually. Yeah. Let's see. I wonder if this, wait, let me check if this is this private? Yeah, it's private. So I have to change that. The whole it's weird that it is private, but I actually don't know why. It's probably on stream settings, right? How do I change the privacy to public? Where do I even do that? Yeah, that's... Can I just change it here? Edit right. Ah, here, never mind. Make it public. Let's go, save. So we should be public right now. Okay, nice. Alright, so yeah. So this is basically my desktop environment, which is a combination of Ubuntu and Qtile. And I have also quite a lot of different packages that just makes me able to do this. It's really cool, actually. So let's put on some music, and I also want to open a terminal and create a directory for the project, or the tutorial project, as you can say. So I'm gonna make the direction here and just say Pytorch -tutorial, something like that, I guess. I can feed into that Pytorch tutorial. Nice. And we want to open this in VS Code, so let's do that. Yes, we can trust this author here. That's fine. Let's also create a remote directory for this. So I will just go to my GitHub here and create a directory. Let's make this of like Pytorch tutorial or real. That, and I'll copy this and put it in the description, and this will also be a public one, so you guys can go and essentially see this repository, and I will choose, I personally will choose users to be able to commit stuff to this, but I will see about that. Okay, so anyways, let's create this and essentially just do this whole thing here, and we can do it in here. So just copy this whole thing here and boom, that should be fine. I'll type in my username And that's the wrong username, so I have to essentially copy paste this whole thing again. It will be fine, it already exists, that's fine. Yep, and then I have to find my password. Yeah, I've stored in a database, so I will just fix that. So I'm just gonna go and copy the password here, and then just paste it over here. That should be fine. So now we have our local repository and our remote repository connected to each other, and we're gonna go out from this so we can actually close this whole thing and go into this folder right here. I will actually just check once more, and that is if we go into, let's see, Pytorch tutorial, and then just ls. Yeah, that's fine. Nice. So remove this. I can also remove that, and now I just have this VS Code here. I also want to close these tabs here, and I also want to have a browser open to the Pytorch tutorial. So we can just go and get started. Now I've already installed all the dependencies and so on, so it's really easy for me to start. Otherwise, I will recommend you guys to follow this tutorial right here. And especially if you're on Windows, then this will actually be really easy for you. If you are on Mac, this might be difficult for you. And if you are on Ubuntu or any other Linux distros, then you have to find the specific installation method. But they are usually the same. So either way. So let's start with the tutorials, I guess. Learn the basics. Let's go with learn the basics. Okay, so most machine learning workflows involve working with data, creating models, optimizing model parameters, and saving the trained models. This tutorial introduces you to complete machine learning workflow implemented in Pytorch, which links to learn more about each of these concepts. We will use the fashionist dataset to train a neural network that predicts if an input image belongs to one of the following classes: t-shirt, top, trousers, pullover, dress, coat, sandal, shirt, sneaker, bag, or ankle boot. This tutorial assumes a basic familiarity with Python and deep learning concepts, which I actually have, because I'm in computer science in school, basically. So, running the tutorial code. You can run this tutorial in a couple of ways, in the cloud or locally. I will choose locally. How to use this guide. If you're familiar with other deep learning frameworks, check out the quick start first to quickly familiarize yourself with the Pytorch API. If you're new to deep learning frameworks, head right into the first section of our step guide, tensors. I will actually go to tensors just to get really all the basics, but I think that's fine. So tensors are specialized. I will actually create a latex file here, pytorch.txe, and I will also find the overleaf layout for this. And yeah, overleaf. We just go into overleaf here and copy the default layout. So I just have the default layout here. Go put it in here. I will change my name to Ramex, for example. That doesn't really matter, and we can change the title to Pytorch. I usually just do this to technically document the whole thing, and then we just kind of view the file, because we haven't done any PDF. Now, I don't recommend you guys doing this, because you have to install certain packages and extensions to VS Code. So just go to my GitHub and follow the PDF file, essentially, or the original documentation. That is what I recommend. I wonder what my Now I'm thinking about it. I wonder what my let's see what the title is of this live coding group. Let's edit that. Learning Pytorch and Python. Yeah. Streaming coding Pytorch and Python until I've learned. I have learned it. Yeah, that should be fine, I think. Yeah, let's save that. I think that's fine. Okay, so let's check this out. Okay, so we have our... I will actually create a folder here that's called docs because... Oh, Jesus. Because I will have it a bit organized. We haven't created a Python file yet, so let's just copy all of these into docs. We can just paste these. Nice. And if we do this now, we should be able to have a PDF file in our Visual Studio Code. Okay, nice. Okay, so let's try to learn these things. Tensors are specialized data structures that are very similar to arrays and matrices. In Pytorch, we use tensors to encode the inputs and outputs of a model, as well as the model parameters. So let's create a... What happens if I copy this whole thing and just paste it in... instead of production, we should create a sub section, or a section that's called sensors. It should be tensors, not sensors. Tensors. And what happens if I just copy... Oh, is this whole... Okay, never mind. We don't want to paste that. Okay, so we start with tensors, and they are essentially like arrays and matrices. It's just a wrapping data class, I guess. Except the tensors can run on GPUs or other hardware accelerators. In fact, tensors and NumPy arrays can often share the same underlying memory, eliminating the need to copy data. See the bridge with NumPy. Tensors are also optimized for automatic differentiation. We will see more about that later in the autograd section. If you're familiar with n-number arrays, or what is ND arrays actually meaning? What does that mean actually? What is ND arrays? An ND array is a usual fixed size multi-dimensional container of items of the same type and size. The number of dimensions and items in an array is defined by its shape, which is a tuple of n non-negative integers that specify the size of each dimension. Okay. But what if we specifically ask for NumPy? Yeah. Okay, so let's see. And the arrays has associated data type objective which specifies the data type stored in the end array. Okay, so it's basically just an array which with a specific data type. Okay. Either way, let's see one thing. I might have to move. Nah, it's fine. Never mind. Okay, let's forget that. I don't have to move that stuff. Okay, either way. Let's try to do. Yeah, let's go and just create some text here. So basically, a tensor is like ND array ND array, but by the way, guys, as you guys can see, I have actually AI that is helping me inside of VS Code, which is really helpful if you want to spell something in different languages. But either way, a tensor is like ND array. ND array is essentially is a multi-dimensional array in NumPy, but with additional features. A tensor can be created from a list or a NumPy array. The tensor can be converted to a NumPy array. Exactly. NumPy array using the text NumPy method. The tensor itself can be used for GPU computations. I think that's a pretty good summary of what a tensor is. A tensor is like an ND array. ND array is a multi-dimensional array in NumPy, but with additional features. A tensor can be created from a list or a NumPy array. The tensor can be converted to a NumPy array using the NumPy method. The tensor itself can be used for GPU computations. Now, I haven't fixed NVIDIA Toolkit on this computer, so I will actually don't use GPU-based computations. I will use CPU-based computations, but that's fine. We are not doing anything complicated or rocket science or everything, so I think that's fine. Alright, so what's the next thing? Okay, so let's try this out then. Let's go to outside of the docs and create a... Nope, not inside of docs, outside. Let's create a... You know what? Let's create a folder and call this project files. Project-files. And create a tensor.py file. Yeah, we can have it here, that's fine. That's actually real fine. Okay, so we want essentially to just type import torch and import numpy as nb. So let's do that, that's my Spotify. Import torch. And I will also have to... No, it can't find... Torch is not accessed. I might actually want... I actually know how to fix that, either way. So we can also import numpy as np. That should be fine, and I have to change my Python select interpreter, I think, to the base conda version, I think. Yeah, this should actually work. Nice. Okay, what's the next thing? Initializing a tensor. Tensors can be initialized in various ways. Take a look at the following examples directly from data. So we can create a tensor from an array. So let's create go in here and create a subsection here, maybe subsection, and let's try to define how we initialize a tensor by our own words, essentially. So a tensor can be initialized by a number of methods. For example, by an array from okay, so directly from data, from NumPy arrays, from another tensor with, you know, let's take this one by one actually. Let's create item list here, itemize, yep, that's really good. And okay, directly from data, from a NumPy array, and from I think it was a list rate. NumPy array, from another tensor as well. It also works from a list, from another tensor, and also from another random distribution, which is actually wrong, I think. With a random or constant values. Oh, okay, now this just shapes the tensor. So never mind. Or does it? Yeah. No? Torch.random. Oh, actually, okay, never mind. Let's go with this explanation. It's actually valid. Never mind. And 5 from random or constant values. Let's see if we can actually get some examples in here. By the way, is the stream lagging? Let's check this. I don't think it is lagging though. No, it's not lagging. Okay. Never mind. Alright, so let's go and try to get in some examples. So this is obviously an example. Let's try to create our own. And this is actually... Okay, so we can type \text just like this with 3 T's. And then type like NumPy code or Python code. So I can essentially type this out. So let's create the data thing. So data is equal to could be yeah. So for example this. You know what? Let's try to create a new row here. Can we do that? I think it was like this, right? Yeah. And then we just carry on with the. So I can actually do this. Yeah, that should actually work. Nice. So we create the data. Yeah, of course. You do that as well. Why does this not work? Maybe I have to. Can I just type it in one row? That's weird. Oh, maybe I have to put a comma and then let's check this out. X.data is equal to torch.tensor.data. Okay, so let's try x underscore data. Data is equal to tensor torch.tensor. Should it be torch? Yeah, that should be fine. And why is this actually not? So missing a $sign, inserted text, extra or forgotten. Okay. Why is this? What if I put another bracket here? Anyway, I can just do this instead. Let's go back like this and then text. I don't know if this is actually the correct way to do this, but either way, I would just do that. This should be fine, I think. And I also have to do this right. What if I remove all of these? That's super weird. But this actually worked. That worked. Why doesn't... Oh, I think I know why. So if I want to type data underscore or x underscore data and then put an equal sign here, this will actually say, oh no, it's a formula or something, or mathematical formula. Oh no, so I have to do this essentially. That fixes everything up. Okay, so we can't use that, but that's fine. But then I actually should be able to do this instead of doing. I think this should be fine, right? I'm spending too much time on this, but that should be fine. Yeah. And then I can also put a loop just like that, and then I will remove this. Yeah. Okay. So directly from data, this will be pseudocode, so it won't really be any real code, but that's fine. We can also do it from, what was this, numpy array, right? So then we create a numpy array and then just transform it, and then it's from underscore numpy. So let's do that. Let's call this, I could actually do that and not do that. And create another text, just like that. Oh, nice. That should work out just fine. So here we have other examples. That's very good. And if we go in, we can actually go in and test these values as well. So let's do that. We're gonna create data is equal to a two-dimensional array, which is basically a matrix, and then we have 1, 2, 3, 2, and 3, and then we have 4, 5, and 6, just like that. And then we can type torch dot tensor underscore data, or yeah, and then we just print. We should actually do x underscore data is equal to this because we want to print the variable. So let's do that. And then we just type this in here and move this up a bit, and boom, we have our tensor right here. We can also do it with the numpy array, so just since we already have this, let's just remove the print and type, let's do numpy array dot array, or numpy array is equal to numpy dot array, and then just print, or actually create the torch, and then just print that, but we don't want to comment. So we have a numpy array is equal to numpy dot array the data is up here, so we take this data, create a numpy array with this data, and then pass it over to torch, which will create a tensor from the numpy array, and then we will just simply print it. Let's rerun this code, and we will boom have the same result, which is expected, by the way. Yeah, so this works, and this will actually happen for the rest of the examples as well. So I can actually remove this. So let's just document this as well. So this will actually create from another tensor, so we can, and I think the AI here will actually understand what I want to write. So let's test it out. Text ttt, oops, just like that, and boom, it should think data and tensor. Okay, so that should be fine, but we still want to have this here, but this is actually wrong because we want to create it from another tensor. So we could actually just copy this whole example here, and that should be the example. We don't need another row here, so let's do that. And yeah, we obviously cannot have a equal sign here, that's fine. And why is this? We can actually have equal signs. What do you mean? That's super weird. Okay, that's quite embarrassing, but why can I have data underscore x is equal to this then? Do I have to have another end row? No. Okay, that's some really stupid shit. I don't know why latex is crying about this. Either way, we only want to have this command here, essentially. So let's go with that. Remove this. We can actually do this as well, and boom. And I think that should be fine. How is that not fine? They have to have a comma here. Nope. Why is this crying? Missing a dollar inserted. actually don't know what the problem is. Is that the problem? Huh, okay, interesting. Oh wait, you can't have underscore like that? No freaking way, man. Like, I didn't know that. Wait, so if I... Oh, okay, and if I do a backslash, then that's fine. Oh, okay, so that's the problem. Then I actually can have data underscore. We have to just do a backslash. X is equal to this. And that should be fine. Oh, okay, never mind. Let's do that then. Data backslash underscore is equal to... This is just latex nonsense, I believe. Okay, and by the way, this is not from a list. This should actually be below this. And this is actually from directly from data. So let's remove this item here. And then just do 3 and 4, essentially. Yeah, and then we have to just... do that as well. Nice, and random or constant value. So we can just go and check here what that actually mean, and this means that it retains the x. So it just creates it creates data based on the shape of the matrix that you add into it. So I will actually just do this. Text.tt. Oh Jesus. Okay. And then I have to just fix all the underscores, which is kind of annoying, honestly. But that should be fine. Just like that, and boom. And we also have to add a new row here. So let's do that, and that should be fine. And yeah, so that's really cool. This will also this takes the shape as input, and this just I think this is just... Why do we even do this, by the way? Oh, this creates a copy with only ones, because we used that once of tensor with ones only, because we have torch.ones like data. So it's, yeah, this should just do from this just converting. Yeah, that should be fine. I think that's quite self-explanatory, and this as well. So I think that's fine. Okay, we're done with this. Yep, from rand attributes of a tensor. Let's go and copy that as a subsection and try to identify that. So, section attributes of a tensor. This is a really good way to actually study, because you can go back to the documentation that you have written later and just restudy everything. And this is basically how I study. Tensors attributes describes their shape, data type, and the device on which they are stored. So we have operations and so on. Over 100 operations, including arithmetic, linear algebra, matrix manipulation, transposing, indexing, slicing, sampling, and more are comprehensively described here. So let's go and check on this link here. Here you have all the different operations, which I'm not gonna go through because there's a lot of operations. Jesus, okay. I'm not gonna, but this is essentially just normal math operations. So if you essentially know the logic behind the neural network that you have, you can essentially, if you know the math as well, you can Oh, you have complex tensors, which is real part is equal to real, and it's... Oh, that's really cool. So you can have, like... Yeah, you can do a lot of stuff with this. Yeah, this is gonna take a lot of time to learn, but you can really do complex stuff with this. Because you could essentially create a matrix that is creating the passive and the real electricity in a machine, basically, with this operation here. And then you can just predict that with a neural network based on input data. Non-zero permute returns a view of the original tensor input with its... yeah, we should not go through all of this here. So let's just summarize this whole thing. So, a tensor... So let's see how many it can find. Come on, it's number 8, my friend. Let's do 10 and then type more. I will also... Yeah, dots, that's fine, and then just create an end with itemized, that's fine. And then we can just do right arrow to that link. And I also have to put this in. Let's do this, I think. Oops. I think that should be fine. The href undefined control sequence. Interesting. So we can't have... how do we actually create an href in... let's go and see. Explain. Fine. Find code smells. Sure. Let's see if we can find the problem here. Yeah, it's relatively straightforward. With better format the input, for example, the text blocks could indent consistently and the spacing around operators could be more consistent. I really don't care about that, so let's just remove this and try to fix this problem here. Ask Cody to fix it. I can also remove this so we can see a lot more. I just want to create an href tag so I can simply just... so if I save this, should that work? That didn't work. What did I even add? I think it has to be some sort of package. I might be wrong though. Oh, it's just... Okay. So that's... It was a weird solution though. Why do we have end document like 4 times? We should only need once. Okay, that's fine. Let's try to figure this out. So let's go here and how to add /href tags in latex. Hyperlinks, nice. We need yeah, it's basically this package here. I think that should be fine if we add it. So let's add this. See if it's... Yeah, that should be fine. And we see the Pytorch documentation. And if I press this, yeah, we won't open. We will actually see... Boom! We have all the different... This is not the... Oh, it's the data types. It's... Okay, so this is basically the whole documentations for the tensor. That's actually really good. Yeah. So if we want to have anything there, just go to this. Yeah, that should be fine. I just have to fix... boom. Pytorch. Here we are. Let's remove these. We can actually have overleaf up here. That's fine. So we have the operators. So we have over 100 tensor operations, including arithmetic, yeah, whatever, we know. Okay, so by default, tensors are created on the CPU. We need to explicitly move tensors to the CPU using .to method. After checking for GPU availability, keep in mind that copying large tensors across devices can be expensive in terms of time and memory. Alright, let's try that. Create some operations from the list. If you're familiar with NumPy and API, you will find the tensor API breeze to use. So it's essentially just creating a bunch of ones here. Oh, I didn't mean to go to the whole documentary, but it creates a bunch of ones here with a dimension of or shape of 4x4. And then first column is obviously ones. First column is obviously ones. Last column is obviously ones, and then you set the one of the, I think it's, yeah, it's the second row or the first row because it's 0 indexed to 0, and then you print the matrix. But essentially what you do up here is create a matrix made of ones which has a shape of 4x4. That's fine. You can also join different tensors. So a thing you have to actually know here is that whenever you use a matrix or some sort of matrix, you have to convert it into a tensor for it to be able to essentially use it. And here we have the dimension of 1. Let's actually standard NumPy indexing and slicing. Let's actually create this here. I want to have this here. Indexing and slicing. Yeah, that's fine. As in NumPy, for example, boom. There we have a very good example, and then we can just do backslash and itemize. Here we have the different ways to do that, and oops, and now we have operations. So we have operations here, that's totally fine. First element of the tensor, this is the first element of the row, first row, this is the first row of the tensor. So here we go, the first element of the tensor, this is the first element of the first row. The first row of the tensor, so this is basically the first value that comes here is the row, and the second is the column. So the first column of the tensor, and then here you have essentially the first 2 rows and the first and columns of the tensor. That's really good to know. By the way, when you do this in Python, there's a much easier and better way to do it, but I won't go through it here right now. Just a heads up. Either way, so we could create a tensor like this, and then just name, yeah, and basically do the slicing and so on. You can also join tensors. So let's go with that. Joining tensors, that could be fine. Let's see if our tensors can be joined using the torch.cat method, for example. And then we have an itemize, and we can do that as well. Boom. We can create. That should be fine. And I don't think, yeah, we can take another group, but that's fine. I don't think we need more. And itemize. Boom. Torch.cat x, y, and dimension. So concatenates the tensors along the rows. Concatenates along the columns, stacks the tensors along the rows. So this, oh, so, okay, so this is a stack, and this is a stack. Nice, okay, so depending on what type of dimension you have, it can either be 1 or 0. No, man. So it's basically like a documentation for me to know what to do when I actually will program my own neural network, but I'm essentially just summarizing the whole Pytorch library into my own documentation, you can say. I also have a testing Python file here, so I guess you can say I tried to combine Pytorch and latex, but I'm just trying to create a fine-looking documentation, I guess. But yeah, you can say so if you want to. Either way. So we can use both concatenation and stacks, and based on the value of the dimension, we either choose to concatenate on the row or the column, which is interesting. So this value, I guess, can only be 0 or 1. And I think that's fine, actually, so let's try... We could actually try this out. Let's try this out. Let's copy this code here, go to our tensor, and try this out. We also have to import, I guess, tensor, right? If I'm not mistaken. Because tensor itself... Oh, okay, so tensor itself is essentially... it should be... No, that should be fine, actually. T1 is tensor, but tensor should be important, right? Or imported. I think... It has to be, right? Am I delusional? Can you save the live for me to download it later? Dude, I'm gonna give you a GitHub link where you can go and check all the code, and the live will also be saved on YouTube as well. So you can go and check the GitHub link and the documentation later, and check also the YouTube live stream later as well. It will be saved on my YouTube channel, so you can go ahead and do that. I hope this actually will help you somewhat, but either way. So let's try to understand the tensors, because just wait a minute. So I think the tensors should be I should actually just be able to do this, and essentially, because we are just wondering what is a tensor, and if I do that, that should be fine. And we also has to, I think I can type from Torch import tensor, right? Tensor, yeah, that should be fine, and I should also be able to remove this. Let's see if this works out. Okay, so we have different dimensions, right? Line 15, which is this line here. Expected tensor as element 0 in argument 0, but got a built-in function or method. So I'm just playing. This should actually not be a... But then I could probably just type tensor is equal to torch.tensor and give this. That should be fine, right? And then just... I should be able to do just cd project -files and then type python 3tensor.py, and boom, we got the tensor, and it prints it as well. So this concatenates the tensor 3 times. If I actually just remove these and print tensor, we will see the default tensor. So if we do that, we get the default tensor here, and if we actually comment this out and take these back, we will see a different value because we concatenated the tensor with itself 3 times. Yeah, same dude. I love those. But it's actually really interesting because neural networks is essentially just a computer which does matrix multiplications and arithmetic and math, which means that you can essentially use neural networks to whatever you want. You can use it to predict language, you can use it to predict money, you can use it to predict natural events in the real world, and so on. And also use it for complex number arithmetic methods, which is essentially something that you can essentially calculate the passive and active electricity in your computer with a neural network, which is real nice. You just have to understand the library, which is why I'm doing this. So let's try to... So we have understood the concatenation. We also have... Yep. So we are done with this. We have arithmetic operations. And this will essentially transpose of a tensor, which essentially rotates the matrix or the tensor in 90 degrees. We can actually just copy this whole thing and see what for ourselves how this works. And you will be able to get this. Your talent and passion are truly remarkable. Keep up the great work on YouTube. I'm confident that with your performance, success is inevitable. Thanks, man. I really appreciate that. I'm just really inspired by computers in general, and I just like to play around with stuff, you know. What I really hope to achieve with this channel is essentially to help people to understand certain topics that either universities or other institutions cannot explain or doesn't explain, because there's more information than a uni degree out here, and I want to help people to understand certain topics as well, and also teach this stuff as well. Either way, so now we have a tensor here. I think I should be able to... I once made a neural network to recognize handwritten digits, but I made it from scratch with no library in Python. Do it was unoptimized, and it took hours for 300 epochs. What's up, Devang? I'm sorry if I pronounced that name wrong. Yeah, dude, I have actually created my own neural network as well, without libraries like... I use some libraries, I'm not gonna lie, but I simply just used Pytorch, no, not Pytorch, NumPy, to create... Is it Dewang? I hope it is. Either way, welcome, dude. So let's try this out. Let's see if we get errors. I think we could actually just comment these out as well, because we don't need them. I just want to test this out. We need that one. Okay. Hey, let's go, dude. That actually made me really happy. Okay, so check uniform bounds, not implemented for long. So the problem is the y3 ran torch.rand-like, which is a transpose of itself. So it's transposing this matrix or this tensor. And have I missed something here? That's weird. Let's check this out. Huh. Why is this crying? Did you have config coding experience before the live stream? Yeah, man, I have. Wait, I might actually want to turn down the volume a bit from my mic because it's super loud. Just wait a minute. So I have coding experience actually, but I usually coded like software and stuff. And now in university I will actually learn to code hardware. So I have the both. I'm aspiring robotics engineering, working robot. That's really cool, dude. Yeah, it's really cool to work with robotics and stuff. I personally like to create software which is linked to AI or neural networks. So I like to combine software and neural networks. That's really cool, and create modules and stuff. So the problem is we have this long here, and I think it's because we don't have... But I have actually a decent amount of coding experience, which is software, essentially. I started to Gen AI. Nice. But either way, so I have a lot of, or a decent amount of coding experience. I started to code when I was 15 years old. I'm currently 21 years old. So I've been coding for about 6 years. I'm still young though. But either way, I have to carry on with this project here. So why is this actually crying? It's so weird. Let's try this out. I don't think I made anything wrong here. Let's see. Okay, so check uniform bounds. Let's see if this... Let's jump this actually, and because it will actually transpose the whole matrix. So that's fine. It doesn't really matter. The tensor tier returns the transpose of a tensor. Yeah, this computes the element-wise product. Z1, Z2, and Z3 will have the same value. That's correct. And single element tensors. If you have one element tensor, for example, by aggregating all values of a tensor into one value, you can convert it to a Python numerical value using item. Okay, so we have tensor.sum, and this is essentially not... So they essentially just convert it to a class of float here, I guess. Which is... I don't actually understand why you do want to do that, or they just type the class, or print the class, I guess. So, oh, they just print the value, and then also the type of the value. So they create a sum, they essentially sum the whole tensor into a variable, and then create an item, which is essentially converting a tensor into one value, and then printing the type and the item as well. And it's normal that it should be a float as well, yeah. Let's type this in our documentation. This could actually be a really good thing to have. So let's actually fix that. And I will also comment this whole thing out, because we don't need this. Nice. So let's fix this, create a subsection here. Just like that, you can remove this. And let's see what, let's just say, a single element tensor is a tensor with one element, for example. Boom. And we can create like another one. x.toList, x.numpy, and create a fourth x2 device. Yeah, that's fine. Slash end itemize. Let's go. So we can just returns the value of the tensor as a Python number. ToList returns the value of the tensor as a Python list. Returns the value of a tensor as a NumPy array, moves the tensor to the specified device. So this could either be your GPU or CPU device, essentially. Yeah, that's really well explained way to do that in place operations. So this will essentially just add a number to a tensor, for example. I don't think that is really valuable to know, actually. It's really basic. So bridge with NumPy. Tensors on the CPU and NumPy arrays can share their underlying memory locations, and changing one will change the other. That's really helpful. So you can essentially transform a tensor to a NumPy array and vice versa. A change in the tensor reflects in the NumPy array. So, oh wait a minute. Do you mean you actually can like? So you create a tensor array, I guess, with 5 values, which is ones, print the values, and then create a numpy array of that array, so it will have the same values, but will be a numpy array, and print that array. Then if we change and add a 1, the numpy array will also change. That is really cool, because then if say for example that you want to run statistics, but you don't want to use tensors, you only want to use numpy arrays, you can essentially link the numpy arrays to, or the tensors to numpy arrays in the memory, and then you can use your statistics to analyze the tensors without even touching the tensors. That's really cool. This is actually really good to know, because when you come to analyzing what data you have and so on, this could be really helpful. Tensor to numpy array, yeah. Let's see if we get some examples on this. I think that should be fine. A tensor can be converted to a numpy array using the text and numpy method. I also want to have some examples here, to be honest. Example... Give me some examples, my friend. Something that helps to learn Torch is projects. I read theory, understood Torch source code, then straight to projects. Yeah, that's really good. You know, it's actually easier to learn code if you start on a project right away. At least for me, I have to do something practical with my hands to actually learn it. So I totally agree with you there. Start project as fast as possible, but I also want to make it easier to understand the theory behind the whole Pytorch library. And this is also a really good way to just memorize certain things you can do and to understand the whole layout of the library. But either way, can we get some examples? Thank you. Then I want to have to the GPU, and that should be basically that's it, I think. So x.numpy, x is essentially our tensor, converts the tensor to a numpy array, and then we have x.cpu. Does this actually work? Let's try this out. I'm not completely sure if this works. Let's do this. So we have a tensor, and we want to convert this tensor to our CPU. So we can just type tensor, just like that, dot CPU. Oh, that actually works, holy shit. And then I can type like, yeah, dot numpy, for example. Convert that, and then just print. I will actually print this whole thing. Just like that, and see if this actually, and I will also print the tensor itself before we even do anything. So this should be written to the CPU, and I think I don't want to. This should be written to the CPU. I think if I write the GPU, I will get an error because I'm not using it. I'm using Linux, yes. I'm using Ubuntu. It's a really easy distribution to install, and I'm very comfortable in it. But yes, I'm using Linux. So let's see if this works. Yeah, that actually works super good. Let's try to write this to the GPU and see what happens. And it's not it's .CUDA actually. Yeah, Ubuntu is really nice. I have a lot of friends that is using what is called Arch, and Arch is really cool, but I have a problem with the installation part of Arch because it doesn't really install the needed graphics. So we have to essentially, yeah, I get an error because I don't have the CUDA library connected. I have it installed, but I haven't connected it to Pytorch yet. Yeah, Arch, yeah. No, it's actually, okay, so Okay, so Arch is really great for certain things, but for installing the graphics drivers, it's actually terrible. It's super hard to install graphic drivers, especially if you have an NVIDIA graphics card. They have, though, created a menu, or installation menu, for you to use. So it's actually easier now, today, to install it than it was before. Yeah, and I will also say it's a bit of a nightmare in Ubuntu as well, just so you know. If you have tried it already and fixed it, then that's great for you. I had a bit of a problem to install CUDA on Ubuntu, but yeah, it's a bit weird, dude. Fedora is nice though. Yeah, Fedora is nice. I actually haven't tried Fedora. I had a friend that used Fedora and then got over to Arch and essentially created a layout that looked like Windows XP on a Linux system. It's super weird, I know. So you can just add here NumPy array to Tensor. It's from, I think I have already written that. So yeah, okay, so Tensor is basically fine. Driver should be updated, then it will work. Yeah. Do you mean about an Arch distribution or Ubuntu? Because I had to update. Either way, we're done with tensors. Either way, let's go and create another. So that whole tensor thing is basically done, and there's a lot of more operations to read about, but there's about over 100 of them. So yeah, exactly. You just have to reinstall the drivers and update them, essentially, and you will make it work. And that's exactly what I did as well. So I totally agree with you, man. So now we should go into, and why is this actually crying? Section datasets and data loaders, and this is saying that misplaced align tab character and. That is really weird. Or just delete the distro. Yeah, I guess you can do that as well. Yeah, I guess that works too, but I honestly feel like changing or updating the drivers is actually easier. But it's a lot of work to actually do that, because you have to find the correct information on the internet, and then everyone goes over to Stack Overflow and essentially mess it up, because Stack Overflow is not correct anymore, or it was. It isn't right now. You know, if you are doing or dealing with Ubuntu stuff, don't go over to Stack Overflow. It's basically the most terrible website for you to be on. But why is this actually not working? You go to the official Ubuntu page and essentially fix your problem there. So let's see if I can fix this problem here. Why is this actually a problem? Let's see if I can. And as you guys can see, I'm not really that accustomed to latex as well. So I have to use a AI to give me some tips here, but that's how coding actually works nowadays. So let's see what happens. I actually have Copilot as well, but I'm using a different AI here, which is free to use, and I find it more. Why is there a difference? Oh, that's the problem. Oh my god, are you kidding me? No fucking way, dude. Oh, so if I just type and here, that should be fine, right? Yeah. Okay. Oh my god. Okay. Never mind. Okay, so let's go over to the data loaders, and I probably won't use this personally when I will develop my own neural networks, because I want to use my own data. Today I had a problem with Grub, Reddit, and ChatGPT just worked. Yeah, that's fine. With Grub, okay, so you're dual booting, right? Do you have a Windows system and a Bluetooth system on your computer, right? Is that what you're telling me? And Reddit and ChatGPT actually works fine, yeah. That's another way to do it as well. Especially when the problem is Grub, because Grub can be a pain in the ass to get to work. So let's try this out. So now we will actually load a dataset from. Yeah, I knew. Yeah. So now we'll actually wait. PCB design software. Oh, interesting. Do you actually need that though for that specific situation? I don't know, man. Maybe. Like, is this a requirement or something? Okay, so let's create a subsection here. Loading a data set, and I want to a dataset can be a dataset can be loaded using the torch.utils.data.data class. For example, here, yeah, I need Windows. But okay, so you're saying, but wait, so you are using Grub, right? And you are essentially dual booting two systems, which one of those systems isn't Windows. Are you using Linux and Mac, or is it just two different Linux systems? Just wondering. Because I have Windows and Linux on this computer. And also my laptop as well. With the same distros and stuff and settings. Yeah, okay, nice. That's good. Okay, so let's see if I actually can just type text here, just like that. I will rewrite this code though. Oh my god, you actually can. Very nice. Let's see if this works. Now dual boot Windows and Ubuntu. Yeah, exactly. That is exactly what I do as well. So here we actually just created our own dataset, which is not what I'm looking for. I'm looking for to just import from the local or their own, what do you call it? Their own let's do that and see if this actually works out. This probably will give me a shit ton of errors, I think. But I will see. I think I can do age space here, right? Yeah. Just like that. I think we just need to do a lot of age space here. And then we have a problem here. Yep, obviously we have a problem. What is the problem? Paragraph ended before text command was completed. Okay. Let's just try to use Copilot here. Fix this. See if this actually works. Let's see if this works. I don't think this is actually gonna work. Yeah, that's not gonna work. Do you have a channel Discord? I don't actually. I haven't created one yet. There's a lot of stuff going on right now in my life. Like, I actually studying to 3 exams right now to be able to study abroad in another country, essentially. Which I'm planning to document as well. So you guys probably will see me like in a different country or something, vlogging stuff, which will be really cool, I think. Either me working for a company or me being in a different country, like Schweiz or Switzerland or Italy or maybe Japan, maybe, I don't know, something like that. I'm from Sweden, actually. I'm not from the USA. No, I'm not. I'm from Sweden. So this obviously don't work. Let's forget about that and try to... let's go with the tensor.py, we can actually create a new Python file here and create data loader.py, and this will actually just make it a lot easier to test our code. This should be fine to save right now. I probably shouldn't get any errors, and yeah, that's fine. So let's try to use this. So we're gonna import. I'm gonna import Torch and import dataset from it. We're also importing Torch Vision and transforms. So we're gonna essentially create a bridge to a tensor, and we're also importing matplotlib to plot the different data. This is actually really basic, and then we just create a training data where we get from the datasets.fashion minst, which is essentially a test dataset from Pytorch itself to make us able to train our neural network based on this data. And this data is essentially just images, so we will create a AI that recognizes images, essentially. And when you train neural networks, you have to essentially have both a test data and also training data, because we will see that later. I don't think we will see that today, but we will see that later. So that should be fine, and let's try to run this code and see if this works. So we're downloading a lot of stuff here. I have to create a git ignore later. So as you guys can see here, if I extend this, as you guys can see, we have actually downloaded data here, and we can also go into the folder that's called data and see all the training data and the text training and test data we have. What do you mean? What do you mean? Why is it funny? Why is Sweden funny actually? What do you mean? Are you saying that I'm not sounding Swedish, or what do you mean? I'm listening to too much American content to sound Swedish. Okay, I think that's fine. And we use Amazon AWS, which is essentially a database service. So that's interesting. So they use Amazon AWS. Or are you from Sweden, my friend? That's why you're laughing. Iterating and visualizing datasets. I could actually, you know what? I could actually do this instead. Let's just create just a bunch of subsections, and then I will take a screenshot of the code and paste it into. That might not be the best. Nah, you're not. Where are you from, my friend? Is it from somewhere in Asia, or is it, or are you living in the UK, or India? Oh, of course. You guys are professional coding people, if I know right. I actually have been having yeah, I know India. I actually have been having a lot of great teachers from India actually coming to my university, so you guys are awesome. Because of you, I actually know more stuff. So I really appreciate you guys. So I will just create like these text here, and then I will add the code into the LaTeX file later, so we can just try this out by ourselves. So it's actually Chalmers University of Sweden. IKEA is best. You know, that's a funny thing actually, because the blueprints from IKEA's products is actually quite bad. I'm kind of low-key hating on my own what do you call it, national mark. IKEA is good for certain things, not all the stuff though. So here they essentially iterate over the different labels. Let's twist this out. So we have downloaded the test data and training data, and now we can iterate over the different labels. So we have label maps here. Then we create a figure, and we create a column of rows, and essentially we loop over all of these and display the images. So let's run this, and we will probably get a window up here. Yeah, there we go. Where we have the training data and the images as well. So this is really cool, and this is just the beginning. So let's try to, yeah, that's good. Close this and clear. We can actually remove this. So that works out really fine. Yeah, so let's carry on. As you guys can see, we actually got the result here as well. And creating a custom dataset for your files. So here we will actually get create a custom dataset. Yeah, okay. So let's copy this, and I will comment out this whole thing here. Wow, that's the button I want to click. And I think, yeah, so we're using Panda, and I will actually comment this out as well, just to create my own, or we can actually just use this, never mind, doesn't really matter. So first of all, if we want to create the dataset, we have to first of all create a class with a custom name. This name can be anything, it doesn't really matter, but you have to take in a dataset as a parameter. And then we have to create a initializing state for that dataset. And this will take in different parameters depending on what type of data you have. So this is where the data analysis come in, and you have to essentially understand the data you get in. And that's one of the hard parts of machine learning, is to understand what type of data you get into your machine. So, and as we know, wait, are you planning to do master aboard which unit are you targeting? Okay, so I'm planning to do a master aboard, obviously, or it's not obvious, but I'm planning to do that. I'm not completely sure what type of uni I want to go to, but I have some countries I would like to go to, which could be Switzerland, Japan, or Italy. And there is, in Italy, I know there is a uni, basically just one university I can go to, which is in the north of Italy, and I don't remember its name, but it is in Milan. And Switzerland have multiple universities to go to, but if I will go to Switzerland, I will not actually attend to a uni. I will attend to an organization with multiple companies in it, and also a large network of engineers. So that could be really cool. Or if I go to Japan, I will probably, yeah, but Japan is quite difficult to access, if you know what I mean. You need quite a big score to get in, but I will try my best. I might actually be able to. I will see. Either way, so we create an initializing state, which creates an annotation files image directory. We don't want to transform, and target transform is none. Self.image labels, which is this class image labels, will be equal to the panda.read scv, which is the file, type file annotations file, which is the name or the link to it. Self.image directory will be equal to the image directory, and the transform and target transform will essentially be the same. So we just link the class to the data essentially here. Then we want to have another function that will calculate the length of the data we have. So here we have to take in our self, which is the class. So we take in a custom image dataset and then calculate the length of the image labels. And this will also be a list. So we calculate the length of itself with the list. So we calculate basically the length of the list it has itself. Then if we want to get an item, we essentially create a function here that has the name getItem, where we take in ourselves as well, and also the IDX, which is essentially the position of that item. So here you can have like lists or hash maps or whatever. It's really up to you, depending on how you want to structure all your data. But either way, so when we call this function, we essentially want to get the image path, and then we call the operating system to get the path, and we join it with the index, because the path is actually joined by the index, apparently. So it's self.image directory and self.image labels, iloc, and then we get an index. So this will get the image directory connected with the index itself. Then we read the image here as well. So we read the image, and then we get the label as well. So we just get the label from that particular index. And then we set the image self transform to the transform, and the label transform to the targeted transform, which is itself. We are not changing any values here. We are only interested in the image and the label. So that's what we do. That's a bit complicated maybe, but if you practice on creating these types of classes, you will essentially see a pattern. I know the pattern because I've done it before. And as you guys can see, by default, the init function is run once when initiating instantiating the dataset object. We initialize the directory containing the images, the annotations file, and both transforms covered in more detail in the next section, obviously. Here we have the labels.csv file, which looks like this. So you have essentially, I can actually show you guys CSV file example here, if you don't know how they look. So they basically look like big tables. And if we, they basically look like big tables. And if we like download this access-code.csv and open it with a program, whoops, I have to do this, open it here. We can essentially see that okay, that's fine. We get a Excel document basically with the values and stuff. So we have the identifier, the first name and the last name. This could be any type of information. It doesn't really matter. So that's how a CSV looks like. And we can actually remove this here. And so we have an Excel document basically, where we get the initial states, you can say. And here is where we get the labels, and the labels from the CSV file is essentially the, let's take up the CSV file example again, so I can actually just demonstrate what labels actually means. So we can download this password recovery codes or whatever minimum data set username on. Let's go with this. Let's download this username.csv and essentially open this. So what labels actually are is these values here. It's the values up here that is the labels. So we get these labels here. Or my bad. Nope, the wrong window. Please, yes, thank you. So we get the labels here. We read the labels from this annotations file, and then we get the image directory, and then we just set the transforms to the transforms. It doesn't really matter. And this image directory here is essentially a link. you can see it as a href link or a hypertext link, but it isn't really the link to a web server or something. But you can see this as a link, and then we get the link and essentially save it to the class itself. So that's how that works. And then we have the function that calculates the length of the information that we got into, which is actually really interesting. And then we can get certain specific items here as well. And then we want now to prepare our data. So the dataset retrieves our datasets, features, and labels one. I'm planning to stream as much as possible, but I cannot promise that I will do this every day, because I actually have a 9-to-5 job as well. So I'm studying to 3 different exams, and I have a 9-to-5, and streaming, and doing personal projects and stuff. And I also have other arrangements to make as well, because I'm sitting in a how do you call it, a section inside of our university that creates marketing for certain companies. So I have a lot of stuff in my life. So I will not promise to stream every day, but I will stream as much as possible. And I will definitely not stream Friday and Saturday this week, because I'm busy. But I will try to stream as much as possible. The dataset that retrieves our datasets, features, labels. All the best for you, grind. Yeah, dude, my whole life is grind, but I like it. I like to have this chaos around me, I guess. The dataset retrieves our datasets, features, and labels one sample at a time. While training a model, we typically want to pass samples in mini batches. Now, if you don't know what batches is, this actually links to the original math behind the whole thing. And batches is essentially, if you think, I can actually demonstrate this. So let's go to GeoGebra. How do you? GeoGebra Classic. That's free. Let's go here. So here you have a 2-dimensional XY plane. And what batches is essentially is, let's just add some points here. It doesn't really matter. Let's just add some points. So I'll just show you guys what batches actually is. So add some points in the negative quadrant as well. We can just add points here, doesn't really matter. Okay, so what batches is essentially is a way for us to say to the neural network, it's a way for us to say to neural network to add a certain amount of points to this graph for every epoch it actually iterates in. And then it will use softmaxes and real use formulas to essentially align how do you call it, a function based on all this data. So if we do that now, I think we will. Now I will just do a linear regression here. It will not be exactly. It will not be the best, but this will essentially. And this is just the basic math behind AIs. This will essentially give us like a. If we use linear regression, this will give us this graph here, because we have. How do I write? Or how do I? Can I like do this? Oh, I can. Okay, that's just too long. So we have a distance between all the points to this graph, and it will calculate the mean based on all the different distances from every point here. And when you have a ReLU is essentially linear regression, but in the negative axis, or the negative axis will essentially be linear, and then it will be exponential and weird in the positive quadrant. So that's basically how that works. I will not go in too deep on that. But batch size is essentially how many points we want to add to every epoch to train the module itself. So let's copy this and let's add these. I will actually write this better later. And we also want to use the training data that we had before, so let's remove that. I think I can just do this and press delete, and that should be fine. I should press delete again. Yeah, that's fine, and now everything works fine. So let's try to see if there is more stuff to do. So preparing data, that's what we do. We prepare the train data loader and the tested data loader. And then we want to iterate through the data loader, which we can just copy here. So I will just explain what we do essentially. So we load a data loader from Pytorch here, or we import the data loader from Pytorch, and then we say, okay, create a train data loader for the train data, which takes in training data. The batch size, which is 64. The best value for batch sizes is usually between 64 and 32, or 32 and 64. And the shuffle is true, which makes it random. If we put this at false, this will not be random data, and we want it to be as random as possible. We do the same thing with the test data loader. So we create a data loader that takes in test data, and the batch size should be 64 dots, you can say, or 64 data, and shuffle the data itself. And then we just create two variables here, which is train features and train labels. So we do the so next is essentially a pointer in the data, and then we iterate over the train data loader. So we have a pointer that's iterating through every through all the data in the train data loader. And then we put the feature batch shape here, so we just print the different shapes. Then we squeeze the train features. I actually don't know exactly what this does. And then we just add the first label from the train labels to the label value. And then we create the plots itself and the labels. So let's run this and see how this works. Okay, so now it's actually just random showing us the different predicted images. So if we actually remove this image here, we will probably get another one, right? Okay, so that's just label 0. If I run this program again, so let's do that. This should be data loader.python, data loader. Never mind, don't do that. When we run this again, we will get another. So this is just, which GPU do you have? Okay, so my GPU is actually very old. I have a GeForce GTX 1060, which is super old. I'm planning to buy a new one, and I think that might actually be the problem to why I don't have CUDA working. It might be the problem, but I have gone to Nvidia's documentation about which type of CUDA version works with different GPUs, and I've tried both and they didn't work. So it might be that my GPU is too old or something like that, but I don't game on this computer, so that's fine. I have a much stronger computer. So now it's just choosing random data from the data we trained. ROCM, what the hell is that? Oh, sorry, what is that? ROCM. Oh, open software stack, including drivers, development tools, and APIs that enable GPU programming for low-level kernel and end-user applications. Is this only for AMD processors? Because I have an Intel processor, just so you know. Does this work for Intel as well? I don't think it does. Or does it? It would be real nice if this works. Let's see. Does ROCM work in... Yeah, exactly. It doesn't work on Intel processors. That won't work for me, which is sad. Otherwise it would work, and AMD is known to have a really good hyper threading processors, and yeah, use CUDA for all GPU. Yeah, exactly. So I will try to fix CUDA later. It's not really the biggest priority I have right now. But it seems like our data loaders and data sets are done. I will actually create a better document. Now try NVIDIA. I have already tried NVIDIA though. That's exactly what I'm using. Exactly. Does NVIDIA have a similar program to ROCm? That would be interesting. I guess that's what you call NVIDIA Toolkit, right? If I'm not mistaken. But I will create a better documentation here later. Now I tried that, let's go and check transformers as well. But I think I will actually stop the stream in about 20 minutes or so. Because I'm getting really tired. I've been up since 5 in the morning to do stuff and work out and going to the gym and also all that stuff. Subsection transformers, let's go. Let's see if this actually, yeah, that's fine. I will create a better explanation for these stuffs here. But transformers itself is actually its own section, so let's create our own section for transformers. And also, nice. So data does not always come in its final processed form. That is required for training machine learning algorithms. We use transformers to perform some manipulation of the data and make it suitable for training. All Torch Vision data sets have two parameters: transform to modify features and target transform to modify labels that accept callables containing the transformation logic. The Torch Vision Transforms module offers several commonly used transforms out of the box. Let's actually just copy this whole explanation. I will rewrite this later, but I just want to have this explanation here at the moment. It's really good. And the reason why it's crying is because I will just do this instead. But I will rewrite this. This is not going to be the final text. Okay, so why is this actually not liking what I'm doing? Missing a dollar sign. So it is a... Is it the minus? That somewhat worked. That's probably the minus, right? Still getting errors. Let's go. I mean, I could technically just do this, but that is weird. How is that wrong? I think it is this minus here. Yeah, so I'm trying to fix this whole thing, and I don't know why it's... Okay, it's just taking a bit longer. That is not the problem, my friend. I'm pretty sure... Okay, so transformers is essentially... But it isn't ROCm CM like a plugin for AMD CPUs, right? Or AMD Instinct evolution case studies. I will actually look at this at the moment. Overview, all AI models and algorithm AI ecosystem optimized for AMD libraries, runtimes, open, proven, ready to start. Yeah, leadership, acceleration, expand support. Key AI support features: obviously transformer engine, highly optimized attention algorithms, and proven collective communications libraries, optimized performance, dynamic FP utilization, optimized high graph, enabling developer success support. Yeah. That's their services. Addressing the most demanding workloads, large language modules, image and video generation, recommendation, computer vision, life science. That's really cool. Machine learning libraries support a wide range of models on Hugging Face. Hugging Face, that's really cool actually. That's really cool because Hugging Face is like a community that is. That's actually okay. Confirm you have a supported AMD hardware platform. Is my hardware? Let's check this out. Support AMD enables the GPUs in the software. Different support will be removed. Unsupported. Supported operating systems. Ubuntu, that's really cool. Visualize software. Yeah, CPU support. Okay, so there it's just. Okay, so there is specific CPUs they support essentially. Is supported on Ubuntu. Support on Ubuntu. So I don't have the right CPU for this program. That's sad. Otherwise, this would be really good. And this should be nice, essentially the same. I will actually check this out more, but I will save this as a bookmark because this is a really good website. And this essentially just is how you install it. From transfers, import G2 tokens. Yeah. T5, Optlama, Bloom, BERT. That's really cool, yeah. Nice work, man. Thank you for the recommendation. I really appreciate that. Okay, so let's try to identify the problem here. So if I pass this here, that should be fine, right? I still get errors. Oh, it's errors up here for some reason. Why is that? It's not the text I just... What do you mean? Why is this the problem? I don't think it's working at the moment. That... Why does it end with this? Remove that shit. This actually worked out before. Why is it not working now? Did I remove the... No, I have the hyperref. So what if I just remove that? It didn't work out. This worked before though. Missing a $sign. Could it be that I have to have a $sign here? Like this? Yep, that's the problem. Very nice. Fix the problem. Nice. Let's see. I'm gonna rewrite this stuff later, just so you guys know I'm not trying to copy anything. I'll just try to explain it better. And this will obviously give me an error, but I think I know the reason to why. It's probably because of this, right? And then I have to remove this as well. And then we have so what if I do this now? And now I just, oh my god, I just deleted the, wait, I did actually just change the, yeah, that's the problem actually. I just changed the whole view. That's my bad. But either way, so what we can do maybe is to create this whole thing as an equation. That might not be working because that works, but it still doesn't satisfy that. But what if I create a new line here? Does that? Nope. Either way, don't. We're just gonna not have this here. All torch vision data set of 2 parameters transform to modify. It could be this. Yeah, that's probably the problem. Let's copy this and remove that link, because that link is really just disturbing us, to be honest. Now it works. Okay. Apparently, if I said this should probably give me, yeah, nice. So it's the link. So I just have to find the link here, which is the torch.vision.transforms. I think that's the problem. So if I do this instead. Yeah, whatever. Let's leave that at that and go here. Yeah, that seems to work out just fine. And I will create a new line here as well. New line here, boom, let's go. And we also have to flush it to the right or to the left, but that's fine, we can do it later. So let's go and check. Okay, so data does not always come into a final processed form that is required for training machine learning algorithms. We use transform to perform some manipulation of the data and make it suitable for training. All torch vision datasets have 2 parameters, which is transform to modify the features and the target transforms to modify the labels. That accepts callables containing. It's 3 AM here, so feeling sleepy. Bye. Yeah, have a great night's sleep, dude. I'm soon gonna go to sleep. It's actually almost 11 here, or it's actually 10 past 11. So yeah, I will also end the stream quite soon. But have a great night's sleep, man. All torch vision datasets have 2 parameters, yeah, transform and target transform. The transform modifies the features and the target modifies the... Oh, thank you, man. I really appreciate that, actually. I try to make it as, how do you say it, fun to watch as possible, because it's code, right? But yeah, I really hope you enjoyed it, and have a great night's sleep, man. To modify the features target transform, yeah, the accept callables containing the transform logic from the torch vision.transforms module offers several commonly used transforms out of the box. The fashion means features are in PIL image format and the labels are integers. For training, we need the features as normalized tensors and the labels as one hot encode the tensors to make these transforms. We use 2 tensor and lambda. Nice. Yeah. So what they do essentially is, and this should be transforms, right? So we create a new Python file here. Not inside of docs. That should be full. Transforms torch.py, which essentially will just import the torch library and the torch vision dataset and the torch vision.transform library, which also includes the toTensor and lambda function. You can actually let's see, here it is. So let's do that. So we find the root data, which is this data here. So we find this data folder here. Train should be true. We also want it to be downloaded if not. We also have the transform itself to two tensors. We create a tensor of transforms, I guess. The target transform should be this function here. And what we do here is essentially say lambda, which is what do you call it? Parameter y, which creates torch zeros, which is a tensor with dimension of 10. So we have a tensor matrix of dimension of 10 by 10. And the type of each value, if this is in this 10 by 10 matrix, should be of a value of float. And we scatter it and essentially do some more manipulation to it. It's really just data management here from the torch vision library. So if we do this, we will essentially download the data. Let's do that and download this stuff. And I think that's fine because we already have it. Let's do this again to just make sure we have it. Nice, okay. Let's try to do this instead. cd project - files and then write Python 3 transforms.py and see if this actually works. I think it should, yeah, now it should download. Nice. So downloaded, very nice. We can clear this and I will continue to use this command instead of the play button up there in the corner. So toTensor converts the PIL image or NumPy end array into a float tensor and scales the image pixels intensity values in range of 1 to 0, which is actually called normalizing. So normalizing is taking the values from the different matrices and create a value that is between 0 and 1. And the reason why we do that is because we can write the percentages in, we have to write percentage values in between 0 and 1. The lambda transformers apply any user-defined lambda function. Lambda function is essentially, if you have done functional programming, lambda functions is essentially a function that doesn't have a name. So it's a nameless function that does certain things. Here we define a function to turn the integer into one hot encoded tensor. One hot encoded, so this is basically hardware, how do you call it? Hardware related stuff. So if we have a matrix of 1 and 0s, one hot encoded means that only one part of that value has to change. So it's, say for example that we have 0, 0, 0 and 1, then we have beneath that we have 0, 0, 1 and 0, and then we have, I can actually type this out, I think. Whiteboard. Give me a whiteboard. Online, whiteboard online, something like that. Just give me a whiteboard. I don't care. Start a whiteboard. I don't care. Just give me a whiteboard so I can explain. Okay, so we have essentially this number. So I have essentially like value of this. This is like the value, and then we have another value, which is, so this is basically one hot encoding. This is 1, 2, 3, 4, 5, and 6. So this should be like this. And then we have, if we can remove this here, and then we have another value. So this is basically just a matrix here, and this should be 5. So it should be like this. So we move it here, and then we have another value. Oops, it's too big of a value. We have another value here, which is gonna be like that, I think. So you see here so the pattern here is that only one index here can change the value from 0 to 1. So that's what one hot encoding means, essentially. So turn the integer into one hot encoded tensor. So the tensor obviously isn't 1 or 0s, it's another value, but the principle is the same. You can only change one value at a time. It first creates a 0 tensor of size 10, which I said before. The number of labels in our dataset calls the scatter, which assigns a value which is equal to 1 on the index as given by the label y. So we essentially give just the label a value, which is equal to a 1, by using scatter function. Yeah, okay, so transforms are essentially... What's up, man? What's up, Roy? I'm actually planning to turn the stream off because I have to go to bed, man. But what's up? So the next part here is to build a neural network. Where's the GitHub link? I will fix that in the future. I can actually fix that right now when I think about it. I'm on the way. No. Should be Pytorch tutorial, right? And I also have to push the whole thing up. Yeah, wait a minute. I can fix that. So here we have all the values. I have to create a git ignore here. Git ignore. And then we don't want to have data, so it should be data. We don't want to have data with, so you have to run the, that should be fine. I think that should be actually fine. So let's try this out. CD, we want to CD the Pytorch tutorial. And then we have here, we should do git status here, and boom, we have created some stuff. The data is still there though, so that means that I just created the git ignore wrong, which is weird. Maybe it should be inside. That's the problem. So we have data and data here. So it should be data, and also it should be dash slash project dash files dash data and slash again. I think that should be fine as well. So let's see if this works. Let's say this still. Let's do this. Have another plan. Create git ignore that ignores the data in current directory. Or just use. It's really that simple? Seriously? So I could just do this. And now it should not give me any problem. It still does so. What type of... Nope, that doesn't really work. Let's go in here and go to ChatGPT to do this. This is really just... Seems about right. That's weird. Git add a dot. Okay, so that actually should be fine, I think. So we should just do git add. Will this actually take 300 years? It doesn't. ls no git status. Boom. So we have the git ignore, we have the git files, we have also the data, which I don't want to have. You know what, whatever, let's just upload the data. I think that's fine, honestly. It's not that big of a deal, to be honest. Git commit this, and first stream, we can say. Git push. Git push. It's their crypt. 0, and then we should just go and check our password. Boom, and I think this will take a bit of time, but I think that's fine. I have a reasonably fast internet connection, so that's fine. Boom, we have uploaded all the things, so let's go to GitHub and check. Boom, we have all the things here, project files, docs. You can also go to documentation and go to the PDF and essentially see what I've written here. I will update this essentially and create a more comprehensive PDF file for you to look at if you want to, and you can also see the code that I have written inside of the streams as well, and I will use the same link as well for every stream, so the link will be the same, and you can just uncomment this stuff to test it out and try it for yourself. Yeah, so I think that's really about it, guys. Thank you for watching. I really hope this helped you, and I really recommend you guys staying and watching through the whole thing as I explain it for you guys. It might be easier for you to understand if you watch me explain the things. We will later create our own neural networks and stuff like that and try to explain this topic a bit more. But thank you for watching and have a wonderful day and have a great night's sleep. I'm going to bed, I'm tired. Thank you, everybody, guys.